All right, welcome everyone. We're giving another minute here to fill in the intro poll so we can get to know who you are. But we are so glad that you have joined us to demystify data engineering and infrastructure. So what you can expect from today is that we'll start with a brief introduction to DataKind, to the session, to the folks who'll be talking today. Then we'll go through the basics so you understand what all the words mean around data engineering and infrastructure. We'll share some examples from real nonprofits of the types of projects that you can undertake in this space. And we'll go into how we can use it and with some hands-on demo, as well as an understanding of the ecosystem, all the different variety of spaces and types of software you can use to support. And finally, lots of resources to apply what you learned with time at the end for questions. And so with that, I'll get us started with a quick introduction. So DataKind is a nonprofit that helps mission-driven organizations unlock their data science potential and help them use data science and AI ethically and responsibly. So we work with volunteer experts and visionary social actors to collaboratively design solutions to tough social challenges that use data science and AI. So I'm Rachel and I manage community programs at DataKind, which means I am responsible for helping our social impact organizations share capacity across organizations and provide events like this to support you all. So I'm so glad you're here. I'm here with wonderful volunteers, Vivian and Vinay. Vivian is a brilliant data scientist and educator with the NYC Data Science Academy in her day job. And Vinay is a former AI engineer turned business side, now doing data product management, going from big tech world to startup world. And both of these folks have tons of experience to share with you. And I'm so glad that they've joined us. And so with that, what are we sharing with you? This is called Nonprofit Data 101, and it is an offering that combines these 1-hour webinars, which you're attending today, with the option to sign up for a free 30-minute one-on-one consultation with an expert volunteer to give you a sense of what data engineering and infrastructure mean and what you can do with them and how you can use them so that you can hopefully not just learn some data concepts, but truly apply it to your work in the social impact space. So this is meant to be a safe space. It's meant to be educational. It's meant to be an opportunity for us to all share knowledge and capacity. And so with that, what can you expect to learn today? In the next hour, we want to enable you to understand what people are talking about when they say things like data pipeline or ETL or data models and more. So get a sense of that vocabulary. We want you to be able to interpret a data architecture diagram, so those are not so overwhelming. We also want to share examples of different types of projects and ways that nonprofits set up their data infrastructure in the service of their mission. We want to give you some hands-on example that you can play with of a data engineering setup and give you ideas so that you can start to think about how data might flow at your organization and how might you be able to use some of this. And finally, make you ready to talk to a data engineer so you can go to office hours after this and say, hey, saw this in the webinar. This is what I want to do at my organization. What are my next steps? What questions or advice do you have, etc. So with that, I'll end the poll so we can get a sense. It looks like we have lots of social impact professionals who are a combination of new to data science and with data science experience. So we will do our best to provide content that will help folks of both backgrounds. And then I'm also scanning the chat here to get to know the rest of you who fall into the other category. So it's great to meet you all, and thanks for being here. And I'm going to pass it to Vinay to kick us off with the basics.
Thank you, Rachel. Hello, I'm Vinay. As Rachel mentioned, I'm a product manager now, fully on the dark side. I was an engineer before. Let's get started. Can you move to the next slide, please? Cool. So I call this a preamble because I already had a preamble slide and I was lazy to come up with a better name for this slide. But I want to start with data engineering. What is it? It sounds like a fancy term, but it's really not. It's just like taking data, collecting data from multiple sources, trying to find interesting things in data, storing it somewhere, and then doing some analysis on it. It's as simple as that. So again, if as an example, if you're a nonprofit that's trying to like do something with healthcare data engineering would just be like identifying the sources of information for this healthcare data, storing it somewhere, and then doing some analysis on top of that. That's the preamble. On to the preamble slide. This is my favorite slide. It's before we go on to the actual basics of data engineering, I wanted to say that before you actually build something out, please do define the problem. What is it exactly you're trying to solve with data engineering? Are you just trying to combine data from multiple sources? Or are you trying to do some analysis on some interesting data? Are you hoping to do some machine learning and all the cool AI stuff that's coming out recently? Do spend some time defining the problem, because your solution depends exactly on the problem you have. Don't just copy paste a solution that might work for some others but may not work for you. And the second thing is think and plan holistically. Don't think just about the data engineering side of things. Think about everything else that's going on in your system. Think about what other stuff will be producing data. Think about the stuff that's going on after the data engineering side. Also think about the cost. You might like cloud is the coolest thing in town right now, but is it the right solution for you? I don't know. Think about it. Cost can spiral quite quickly. So think about what budget you have, what budget you might want to have place for this specific thing. And also think about short-term, long-term needs and plan accordingly. And the last thing I would say, don't get married to a solution, iterate. If you build something out, it doesn't suit your needs, throw it away, build something new. Don't get fixated on one solution because you built it. Cool. Moving on to the big scary slide. If you understand everything on the slide, the next 5 minutes is going to be extremely boring for you. Tune out, get it, you get whatever. But if you don't understand everything, hopefully you'll find something interesting here. This is a data architecture built for a biotech firm in London. It worked well for them, but may not work well for you. So this is just an indication of how a data architecture would look like in real life. And again, this is using a very specific architecture model, very specific technology that worked for their company. It might not necessarily work for you. As we go through the next few slides, we'll take each of these different components and try to figure out like what are the different components in data engineering. If you have any questions along the way, just pop it in the chat. We'll also have a Q&A at the very end. Cool. So the very first thing, data sources. This is very simple. Like, what are the source of your data? Are you getting this data from an Excel file? Are you getting this from a database that's already in your system? Or are you trying to get this from an external website like data.gov in the UK or nhs.co.uk in the UK? It can be very different things. Figure out first what data you want to get, and then figure out where you're getting this data from. That's the first one. Moving on, the next thing is data pipelines. And you'll hear this term ETL thrown about quite a few times in data engineering. Nothing super complicated about it. It's just extract, transform, and load. Extract is basically trying to get data from one source or multiple sources. And transform, the next step, is either combining these multiple sources or trying to find interesting things between these two different multiple sources. And then we move on to the last step, which is load. You combine these different data sources. You have this nice data set. You want to put that somewhere. That is the load step. If you click on next. And the data pipeline is just a way to refer to this ETL process. So yeah, that's exactly what it is. It takes data from one place and puts in different places, Moving on to the next step, which is data pipeline. So you already defined the data sources, you know where data is coming from. The next step is doing something with the data and putting it somewhere else. So this step is doing something with the data. And there are two kinds of popular architectures. One is near real time. The other thing is batch mode. And the main difference is how quickly do you want the data to move from one place to the other. So in a near real-time system, if there are things happening in real world and you want instantaneous or near instantaneous access to data from source A to source B, you would build something similar. In batch mode, you do it like in batches. Say you get a batch of data every day, I don't know, from maybe a government resource. You want the data to show up in a different place at the end of the day. So you would just run a job at the end of the day, copy all the data from source A to source B. So that's the main difference. Like, how quickly do you want to have access to this data from source A to source B? And a few terms here, big data and not so big data. So big data is basically any data set that has lots of columns and billions of rows. I do like kind of emphasize lots of columns. So as an example, one of the data sets we built, we had like 15,000 columns, 1,500 columns about a user. And we had like billions of users. That's big data. If you have like billions of rows, but I don't know, one column or two columns, that's not really big. So don't worry about all the big data tools that the market will throw up at you. That's very important because like you keep hearing about all the big data stuff that's happening in the real world, but be very sure to know if it's actually going to be useful for you or not. Next slide. And then the next step is putting the data somewhere, right? We identify the data source, we move data from one place. Now did something with data, we want to put it somewhere else. So that's where we have our databases and data lakes. And it's essentially at the very basic level, a database or a data lake is a place where you store your data. It can come in very different flavors. There are thousands of examples of databases and data lakes. So again, I keep saying this, but it's worth repeating. Do know what you have to do and what works for you. And also plan for the next stages. At a very high level, a database is where you store all your data that comes from the application stuff. A data lake is more of a long-term store. So if you want to do analysis or if you want to store random bits of information, you'd probably put that in a data lake. If we move on to the next slide. I just want to take an example and explain database and data lakes. Again, if, for example, you're a nonprofit clinic, where would you use a database? Where would you use a data warehouse? Where would you use a data lake? As an example, in this specific scenario, if you're getting like patient demographics data or medical history, for example, you have patient X is age 37, they live in, I don't know, some postcode, and their phone number is that. You would store information like that in a database, and you'd store how many times they visit a hospital and all of that. A data warehouse is typically where you would do most of your analysis. So you want to figure out how many people in this specific postcode have diabetes, for example. You would do those analysis on a data warehouse. It's usually used for processing like large amounts of information, billions of people, as an example, and then you do the analysis on the database. A data lake is quite similar to data warehouse. So in the modern world, kind of merging data warehouses and data lakes together. But a data lake is so much more than a data warehouse. It can store any kinds of information. So it can store all the processed information about your demographics, your population health, how many times a person has visited a hospital. But it can also store like unprocessed data. It can store like an image of an X-ray. It can store like a screenshot of a physician notes and all of those images. So that's databases and data lakes. Essentially, you decide on what data you want to store, how you want to store it, and then figure out the solution for that. So far we figured out like where we're getting the data, how we're processing the data, and where we're storing the data. The next step, and the next three steps are quite optional. It depends on what exactly you want to do with this. But the next one, which can be useful for you, is visualization. So you have this data sitting in a very nice database or a data lake. What would you want to do with that next? As an example, you might just generate an Excel report on top of that. You might say, I don't know, that in my area, there are 1,000 people with diabetes. So that's something that a non-tech person can understand and can see. So you might want to present that in an Excel layer. Or you might want to show some graphs about how a particular health outcome is changing in your area. So there are vast number of tools to do all of this analysis and visualization. And Vivian will talk about this in a few slides. But again, the point of this is figure out what you want to do, and then pick out a solution that suits your needs and your database. Next one, applications. And again, this is so much more dependent on what you want to do. So once you have the data in your database or a data lakehouse, you might want to provide access to this data to someone else through these things called APIs. Or you might want to put some web application on top of that, so you can check it on your phone, or you can check the data on your browser through different applications. Again, this depends on your particular problem, but you can build a lot of things on the data that is sitting in your database on data lake. So yeah, that's that. The next slide, please. This is, I guess, an exciting slide. Now that you have your data in your database and data lakes, you've done your visualization, the next step you might want to do is do some predictive stuff. Sure that, for example, diabetes in your area might be going down in the last X number of days, but you want to forecast that for the next Y days. So you can use a few machine learning tools to do some of these. There are a lot of no-code ML tools that you can just plug onto your database, and the no-code tool would just look at the data, figure out what trends it's observing, and forecast it for the next whatever amount of period. I mean, if you have a machine learning team and if you want to invest in it, they can build these tools for you, build more complicated tools for you. But if you don't worry too much about it, there are no-code solutions as well. So again, like, figure out if you really want to invest in this. And that's like quick journey through all the different components of the data engineering thing. I mean, hopefully, like, this made sense. This is just an example of an architecture. If you have any questions, pop it in the chat, but over to you, Rachel.
Thanks, Vinay. I hope everyone is not so scared anymore by this slide that might have been big and scary 15 minutes ago. I'm seeing some great questions in the chat, and I want to encourage you to copy your question and paste it in the little Q&A thing. So if you click on Zoom, you can see Q&As next to chat. We will be able to track the questions a lot more easily in Q&A, and we are more likely to get to them. So if you want your question answered, put it in Q&A, not in the chat. But that said, now that you've got a sense of the vocab, you can look at a data architecture diagram and it's not so scary. You see all the different pieces and what they each mean. Thanks to Vinay, let's apply it with 3 examples from nonprofit organizations. So first, we have an example with New America and the Eviction Lab. DataKind worked to bridge the eviction data and analysis gap. The essential problem here is that landlords in the US file around 3.6 million evictions each year, but still we know very little about the reasons for housing loss and what the impact is. So having access to that data and being able to act on it is very crucial to helping with housing insecurity. So there were 2 different barriers that we're trying to address with this project. First is the eviction data gap. The data that's collected by local counties really vary in quality and how it is accessed, and it's not standardized, not available in real time. And then, of course, on the analysis side, you can't housing leaders, data journalists just don't have access to the data to be able to learn from it and apply the learnings to policy. And so that's why the team, DataKind and New America, built the FEAT tool, the Foreclosure and Eviction Analysis tool, to close that eviction analysis gap. And so this is a data engineering example that might be really similar to what you're working with. If you have some type of analysis problem where you have different data sources that you need to get access to, and that it ingests all the data, cleans it, standardizes it, geocodes it, and then provides that analysis so that it can be used at the end of the day. Now, for a less scary slide, what does that look like in a data architecture diagram? So we've just got 3 steps here. Your first journey with data infrastructure might just have 3 steps. So we've got our data inputs, where we have these records about evictions and about foreclosures. They're not aggregated, and they just have dates, geographic identifiers. And then we go into transformation. So remember the ETL process, this is the transformation piece, where we clean the data, we standardize it, we bring in census variables and do the analysis, which takes us to finally the outputs. And that's the analysis, the visualizations, and those time series charts that provide the answers to the organizations. So hopefully this gives you an example of what it might look like for you to get started with data engineering. But I'm also going to take us through a second case study that has a few different types of data engineering challenges and problems that you might face. So the Harlem Children's Zone is a nonprofit that breaks the cycle of poverty in Harlem in New York City by serving 26,000 individuals each year. And they provide support in key developmental stages of children's lives to help them disrupt generational poverty cycles and improve the long-term health of the community. So Harlem Children's Zone has been around for a long time, and its database of clients has also been around for a long time. So they have records of individuals that date back to the 1990s. And maybe you're nodding your head, maybe you work at a nonprofit that also has records of individuals that date back to the 90s. And you probably can relate that this data is inconsistent. The locations are really different. There's different names. There's people have new last names. There's just address changes, a lot of a big mess with the data sometimes in these situations when we've had data for a long time. And so their goal was to improve data collection, management, and retrieval systems, and get that high quality data so that they can identify their clients at risk and actually use the data and forecast future needs. So this project involved a few different elements of what you might find useful at your organization. First element is a schema map. So if you have a lot of different data and different data sets in different places, this type of output can give you an idea of how the data is organized and stored in what's called a relational database, which just means data sets that are related to one another with something that connects them, which is what the little arrows are in this diagram. So maps like this are important because we need to know how the data is structured to help us understand on the front end how we should use it. And then another thing that might be useful for you as an organization is identifying duplicate records. DataKind, we've internally gone through this where we've looked at all of our records of volunteers and partners and deduplicated. And a lot of social impact organizations need to create good systems for deduplicating their records because that helps you trust your data and ensure that your results are accurate when you're looking at your data, and therefore you can better serve your clients. So that's another deliverable that you might take as your first takeaway here is I'm just going to focus on deduplicating. A third piece of this project that could be relevant to you is standardizing. In this case, we standardized addresses so that they could be pulled into the Google API to put on a map. And so this is an example of Python code that does that, but you might have different types of standardization needs that would be part of your engineering project roadmap. And then finally, DataKind built a tool that brought together internal and external data to inform how many births are happening in the zone, and that informed programmatic planning. So that brings us to a fourth example of a type of data engineering work that you might decide to do as a social impact organization getting started in this space, which is merging internal and external data sets to inform your decision making. So we just talked about 5 different data engineering tasks or projects you can undertake across 2 different case studies that could help you further your mission. And our final example that you might have to undertake is a vendor selection process. This could be a next step if you know you need some type of space to put all this data, but you don't have it right now. And so Grameen America reached out to DataKind for advice on selecting vendors as it revamped its data and analytics platform. Their goal was to modernize the infrastructure, create dynamic dashboards, and automate existing routine reports. So DataKind identified vendors, created a short list, tested the tech stacks, and finally developed final recommendations. So what could this look like for you if you need to undergo vendor selection? Start with the criteria. DataKind helped Grameen America come up with these key criteria of what's a showstopper, what they need, and what they want as they're looking at their vendors. And then go through a process to understand what vendor has what. So I've removed the vendors from this chart because I don't want you to think that one vendor is better than the others, because it really depends on your criteria and your needs and your constraints. So the DataKind team looked at lots of different vendors and ranked them based on the different criteria that you'll see here, including integration with certain platforms that you might not be using. So that might not be relevant to you, but you can use a system like this to make your own vendor selection process. Finally, DataKind came up with a comprehensive recommendation set to select integrated vendors for their new internal data analytics platform. And so you can see at the chart at the bottom here uses some of the terms that you might now know thanks to Vinay's presentation, where we go from data sources and we ingest that data using extract and load, and then we store it in a data warehouse. We use a transformation tool to transform the data, and then finally visualize and deliver with business intelligence tool. So I'll quickly share one example of a recommendation provided with a few different software options. This is not a recommendation for every organization or for anyone in particular. It's just an example of what that might look like, in that made sense for extracting and loading the data to use Talent Data Fabric, storing the data in Snowflake in a data warehouse, and then finally reporting with Power BI. And that was the right fit for this organization, but maybe not for you. So with that in mind, what other options are out there? I'm going to pass it, stop sharing my screen so that Vivian can walk you through the ecosystem and different examples, as well as a use case of what this might look like.
Thank you so much. I'm taking over from here. Cool. I'm glad to have an opportunity to introduce you the ecosystem. So let's first look at a big infographic. I know everyone have seen this kind of infographic before. So if you look at the color coding, each color present a specific field. On the top, orange portion present infrastructure, red portion present analytic, purple is machine learning, artificial intelligence. Between purple and pink, application, enterprise, application, industry. Then the green part is open source. The blue part is data source, API, and data source. So we can zoom in to take a close look and see what's going on in our current ecosystem. So infrastructure layer, you probably have heard a lot of those names in the past. If not, don't worry about it. You will get familiar with them. So first off, there are a lot of popular storage solutions such as Amazon S3, Google Cloud. In Hadoop part, basically Hadoop is the distributed computing system. So for example, if you want to count all the books in a public library, you can send 50 to 100 people to count each bookshelf. When they come back to report you the number, you can add them together. This split and combine process is very commonly delivered by Hadoop system, which allow you to handle computation intensive tasks. So those are a lot of famous vendor in this category. And you probably heard a popular word called data lake these days. So right now, everyone tried to store their data into a data lake and make sure it's all accessible by different departments under different authorization. So data lake is like store all kind of data. And more traditionally, you probably have heard about data warehouse. And a lot of companies require real-time computation, so they might care about streaming and in-memory database. And if you're coming from more traditional computer science background or have been in the field for a while, you must have used RDBMS. It's Relational Database Management System. And if you have experience with non-structured data, you might heard about NoSQL database and NewSQL database. And again, if for special industry need, you might need to use real-time database and graphic DB. So for example, if you're AT&T, you try to pull out everyone's billing details, that's called real-time response. You need to use some real-time database. Graphic database, more similar, like if you're ordering food on DoorDash, they need to find the best way to deliver your food with the best carrier. It's a graphic computation problem. How can they assign the delivery man with the minimum delay to deliver multiple orders at the same time? Cool. So this is the fundamental backbone of the data infrastructure. We can move on to analytic. There are also a lot of great vendors you probably heard or used before. I want to point out a few like Tableau, Power BI, Order YX, Google's Looker. Basically, they allows you to do a lot of data analytic tasks with the minimum coding work. You can drag and drop, and you can easily connect to your data API and constantly get updated data. And you can put together a dashboard to address your business need. You can transition data from one source to the other. You can generate modeling. So it's pretty handy once the dashboard is built. Then I want to move on to the machine learning and the AI portion. Today, I'm going to demonstrate some solution right after this particular chapter. So Databricks is a lab raised in UC Berkeley. They initially proposed a solution called Spark. It's considered as like 100 times faster than Hadoop solution. So it become really trendy, and they use something called solid state hard drive to replace in-memory computation. So the computation cost is also much lower comparing use pure memory. It's like combination of memory and solid state hard drive. And Data Robot, Data IQ, Domino Lab, H2O AI are considered a very popular and machine learning platform. They actually go beyond machine learning. They actually offering end-to-end solution these days. So you can have your data infrastructure, have your analytic, have the ETL, have industry application. So today I plan to introduce a few user cases in this category. And based on your own industry, you can find a lot of similar applications. So if you're coming from enterprise and you're focusing on marketing, those are the apps you can look into. If you're looking into marketing, instead of doing B2B or doing B2C, those are the solutions you can utilize. If you care about data security, those are the solutions you can utilize. So it's very vertical heavily designed. If you care about, okay, what are the specific user cases in my industry? For example, you're doing government intelligence, Palantir is a great solution. If you're doing commercial, you can utilize like Shein, Instacart. A lot of companies are grown to the stage pre-IPO, means there are a lot of users using them. There are a lot of revenue generated in those industries, which also show the maturity of this industry get to a certain tipping point. So let me move on to the open source. So about 10 years ago, I can feel a very big shift from closed source to open source. Even a major software company have like 10,000 or 20,000 people develop software. It's the update and the community support still cannot compare to open source community. Like our language, Python language, you can easily find millions of people supporting it and try to patch it, adapt it, and update it constantly. And a lot of them are domain expert. So if you find any problem, you will see open source community patch it like in no time. With this idea behind, you probably heard a lot of open source projects in this field. One famous one is Apache Airflow, Kubernetes, and Spark. You also probably used some of them in the past. I think like here is Kubernetes, here is Docker, here is Red Hat, Spark SQL, Hive, MySQL database, NoSQL database, Airflow. MLflow is a end-to-end solution for machine learning ops. So you can deploy a model, you can keep it running by monitoring the progress. And the last part is data source and API. So oftentimes when you introduce analytic project, you want to combine with other data set, like Twitter API, like US Census dataset, CDC disease dataset. So API allow you to get data in the right format without like downloading or storing other people's dataset. The last one is data sources, like incubator, schools, research centers. Okay, so this is one of the overlook of the ecosystem. I also want to introduce one user cases. For example, think about how you manage your own data. Usually you start with ingestion. You want to suck the data into your platform, either into a dashboard or some kind of analytic platform. There are a lot of ways you can do it. Like data transformation is also always challenged because the data format definition is different from platform to platform or software to software. So those software enable you to do minimum work. Once you have it, you store them in your either data lake or data warehouse. And you come up with your business need, how to analyze them. Then operation-wise, like for example, okay, this data set wasn't downloaded completely. You need to reverse this data downloading. So reverse ETL allow you to roll the data back and get to the right data record. You also can use AI and the apps to make sure this process is as intelligent as possible. When you have multiple data sources from the different database, you might want to use like Airflow, Shipyard, Dataster to automate this process. Also be able to monitoring what's going on. And transformation comes in when you have more data resources serving different dashboards, serving different modeling need. And when you consistently update your data and model, you want to have monitoring software in place to allow you to monitor like what's the data shift. Is current this month's data 70% similar to the data set I saw last month? Or is the model similar to what I built previously? Do I need to run the model again? Because running model and be able to come up with new parameters are very expensive. If you have PB level data, rerun the whole model probably costs you tons of money. So monitoring tell you what's going on with the data and model is very effective in regard of controlling costs. The last part is management. Once the whole process is done, you want to have a good sense of how things are going and are they serving your business need still. Okay, so page 40 is an overview of all the vendor. Like it's not a comprehensive solution, but it's a good start. The modern data stack is like one small cases how you can build your own internal data stack. Okay, next I want to introduce the resources you can use to apply what you learn. So for example, all the big data solution, Google, Amazon, Microsoft are the three major vendors in this field. They all offer great community support. So you can find a lot of training video. You can find like step-by-step tutorial pages to help you start to use those solutions. Google and Amazon also offer 100,000 free cloud credits. So if you're a startup or nonprofit, you can apply for such credits for your venture. Azure offers something called quantum credits. Usually you can get 500 for free through quick approval process. I'm not aware if they have a special award for startup or nonprofit, but feel free to explore further. And all the solutions enable you to build general AI application, machine learning application very quickly. They pre-build and you only need to drag and drop to utilize their advanced technology, which make everyone's life easier. And you can build your model on the top of their existing application. Also, all of them have a very rich product offering. Like if you click any on those links, they probably offer 200 to 300 different products in each domain of this ecosystem. So you can fully utilize their offering to build your internal modern data stack without like try to put a mosaic together. Okay, so the next page, I want to introduce a few end-to-end tool, which including like DataIQ, H2O. So DataIQ offer 14 days of trial license. This platform including data prep, visualization, machine learning, data ops, machine learning ops, and analytic apps. I'm gonna show you an example very quickly so you can start to utilize them with the free license. Also, they have an amazing up-to-date plugin library. Means you can plug in like ChatGPT, you can plug in like vector database and whatever the latest available new technology on the market. They packaging it and make it available through plugin library to you right away. So on this platform, you can prepare your data, come up with simple visualization, run some machine learning model, make sure your data ingestion and transformation is handled by data ops, make sure your model is deployed correctly with your immersion ops, and finally, you can connect to like industry specific analytic apps to serve your business need. And for H2O, they're famous for their auto ML offering, which means you don't need to pick your own machine learning model. They will check your data and find the best model for you. And H2O is also famous for being completely open source. Their business model is to offering consulting service if you use H2O to help you build a better model. And their computation is highly optimized, so it's distributed in-memory machine learning platform. You can run on your own laptop or run in the cloud. Another great feature is they have a no-code deployment, which means you don't need to write your code. You can drag and drop to use their offering. The last one, I want to introduce a few business intelligence tools, including Tableau and Power BI. These are the two apps building by different software, but as you can tell, they're quite similar. You can pick the color scheme. You can decide what kind of like box plot, histogram, or scatter plot you can make. So you can fully design the style, like color, fonts. Okay. Last, I want to move into a hands-on live demo. If you double check the chat, I put a link there. So the link is, I can post one more time. It's easier. You can click on dataiq.com solution.category. Go down 3 row, 1, 2, 3, 4. The 4th row, we're gonna go over the social determinants of health in United States together. So I just give you 10 seconds to get on this app. Once you get on this card, you can click it. It's gonna bring you to this page. Okay, so I'll get started. So this particular project is researching the condition in the places where people live, learn, work, and play. How does that impact the quality of life, the risk, and the outcome? So through this app, you can collect and collaborate data through API using US Census on community social factor condition, also CDC disease data. You can dynamically explore the data pattern, like what's the cancer rate, how cancer distributed across different states. you want to identify patterns in community level, so you can tie the trend to the disease. You can utilize descriptive analytic charts and unsupervised machine learning and try to find the most important social fact to create this disease. So by clicking into this app, you can find interactive web dashboard. You can find a reproducible data workflow. You can reproduce the whole analytic project. You can also find a very explainable model instead of like looking into a black box. You can choose region and segment to see what kind of skill program and outreach effort is required in different region. The last is what's the social determinant healthcare score and market access, care, and coverage. So if you click on Let's Go, you will be able to open this page. So this is the first stop when you start your application. In this page, you can find Go to Flow button. You can find dataset. You can find the recipe. You can find models. You can find notebook. You can find analysis and dashboard. I'm going to explain them one by one so you have a sense how to use them. If you click on Go to Flow, you will come to this page. This is a dashboard for overall how this project is built. If you slightly click on the first, you will see, okay, this is a census data set. You want to research the social environment factor. If you click here, you will see, okay, this is the data preparation step. You may like update the dates from string to data type, or you want to convert certain data set into new format. The second one is the CDC data preparation. So once you have the original data set, you want to update them, ready for analytic and modeling purpose. Then you move into modeling. Like if you click into each step, it's actually tell you what is done there. Whatever done there, it's called recipe. So you can have the code, you can have the pre-processing job and the drag and drop steps. Then this one is segment analysis. This one is metadata. And the last one is the visual insight. So it's corresponding to what we said earlier. You start with data preparation, slide visualization, machine learning, data ops, machine ops, and analytic apps. So if you click on if you go back to the original first stop and click on 72 dataset, you will open a dataset. So you will see, okay, this dataset is census tract percentage data. This is CDC disease data. This is a final dataset track. This is metadata, a preparation and drawing the data. So you can click into them to see the detail of the dataset. And next, you can click on the two models. Once you click on the model, you can see, oh, the user regression model, the user clustering model. If you care about the detail, you can go inside and update them as you wish. Then I want to show you the dashboard. If you click on the dashboard, you will open a page like this. So tell you, okay, the end product of this project, you have 3 dashboard: solution build as a user menu, and analytic and track segmentation, disease prevalence modeling. So if you click on the first one, you will see the user menu. So basically, it's guided potential users through your analytic. You can see there is a map distribution, heat map, data table. You can see the tracks segmentation from k-means. You can see the disease based on different region. You can see the rigid regression and the coefficient of the model. You can see Sharpie additive explanation. So if you click on run or run now, you will be coming to each individual dashboard. So you can choose different disease. If you care about heart disease, you care about like California, you care about different county, you can dynamically generate your analysis. So this is highly adaptable to end users' need. You can say, okay, I care about the prevalence between 4.5 to 9.2. What are the county are not doing well? And what is the main reason? And you can go into the tracks level to see what's going on. Are they having poor living condition, or they have poor house social economy status? You can also go to the regression model and find out what are the most important factor. Like for this example, cancer, not including the skin cancer, the top 2 variable to impact this result is the percentage aged 65 and older and was disabled in the track. So this coefficient kind of like rank the importance of the variable, and it's very easy to sort them. Like you can sort by the name of the variable, you can sort by the coefficient, you can sort by the trust. So it kind of like give you a good way to see what's the main impactful variable for a different model. You can also look into individual explanation, like what's the most inferential features in this particular track and this particular track. So you can compare tracks side by side. Okay, that's pretty much it of my introduction. I'm gonna pass back to Rachel.
All right, it's time to get into questions. Thank you so much to everyone who has submitted questions. We've been trying to answer, Vinay and I have been working during Vivian's presentation to answer as many as we can. So please take the time to review while we're talking, but we'll go through some of them. Definitely won't have time for all of them, which is why I want to really encourage you to sign up for office hours. I'll send the link to that in the chat very shortly. And that will be an opportunity for you to chat for 30 minutes with the data engineer and get all of these questions and more answered. But to start with a few, Vinay, do you have one you want to get started with answering live? Is there anything you'd like to kick us off with?
Sure. There are a bunch of questions about privacy. I can start with that. And I guess someone already answered that there's going to be a separate webinar on privacy. But just to kind of quickly answer that here. So one of the reasons I didn't do like a separate privacy pipeline is because you can conceive a privacy pipeline as a data pipeline. It's essentially reprocessing the data and deleting it in a way. And also, apart from that, like your privacy pipeline depends on the stuff you're doing. It depends on the market you are in. So a healthcare industry, a healthcare company might have a different privacy restrictions to a financial company. It also depends on the market you're operating in. So if you're in the EU, UK, or most parts of the US, you'll have to go through GDPR. If you're in California and New York, there are like very specific privacy laws governing those states. So it really depends on your region. But in general, someone actually pointed this out, I would put some restrictions on data retention and do some kind of purging based on how frequently the user has used your system. As an example, if a user has contacted you like 10 years ago, it's probably, and they haven't done anything with you ever since after that, it's probably not right to store that information. But if they've reached out to you 2 years ago and they made a few transactions with you, and since then, if they've been in touch with you, it's probably okay to store the data. Again, so privacy is like a huge topic. It really depends on what you're doing with it. But that's the start. So I wish I could give like one definitive answer, but I keep doing this every day with my legal team about the stuff I can store, I cannot store. So it's a huge topic.
Yeah, thanks, Vinay. And it's so huge that we're going to do our next session on it. We're going to talk about data governance and security, which will definitely get into privacy and the specific needs for nonprofits. So make sure to be on the lookout for the invite to that in your emails. Vivian, is there a question that you want to make sure we answer live?
Yeah, I see a few questions related to my part. One question about census tract. So basically, if you use a zip code to research certain region, in fact, it's too big. But census has a way to break things into tracts. So it has a boundary of longitude, latitude. So with tracts, each community is roughly comparable size.
Great. I'm seeing a lot of questions about data quality, which is a huge area that we've done lots of work, and there are tons of tools. But are there any recommended resources for streamlining data audits, for compliance or bias or data quality? Anything that you all want to share on that topic? There's a lot of options. Okay, Vinay, what are you thinking?
I don't have an answer. It is a difficult problem. I never used an off-the-shelf tool because none of them work for us. So yeah, sorry, I don't have an answer. Yeah.
No worries. Yeah, and feel free to come to office hours and ask about your specific data quality needs, and the data engineers in office hours will be able to help you find the right tools that might be most helpful for you. One more I'll quickly answer is, where does EDA fit into this life cycle? EDA stands for Exploratory Data Analysis, and that typically falls on the end once all your data is together. If you imagine the diagram in front of me, on the far end where you have analysis and data visualization is most often, but you also might do some at the beginning to figure out how things should connect. Do you all have anything to add about EDA? Good, Vinay and Vivian. All right, well, we only have 3 more minutes, so we'll try to answer a couple more by typing in these last 3 minutes, but otherwise, all of these questions I know are amazing 9 office hour data engineers would be thrilled to answer. So I would highly encourage you to sign up, and Sheena's going to put the link in the chat for that. So, but we'll also send it via email, and here's the information. So as a reminder, we offer 30 minutes, one-on-one consultations or 3-on-1. You can invite your team to all meet with a data engineer together. And they're available throughout April at many different times to connect with brilliant data engineers, and they will talk to you about this stuff and answer any follow-up questions, help you think about your projects you want to undertake, think about your infrastructure. So please take advantage of that offering. And then, of course, Nonprofit Data 101 is not just data engineering and infrastructure. We started this series with a webinar and office hours on data project scoping and identifying your problem, which is the first thing Vinay talked about. You remember Vinay's preamble slide? He said you have to define the problem well. So if you want to watch the recording from that, that might help you get set up in your data engineering and infrastructure needs as well. We're sending the link to that in the chat. We'll send the recording from this session in your emails tomorrow, so you can share it with your colleagues or rewatch it if you'd like. There's a survey going in the chat right now that you can please fill out to inform us of what would be most helpful for the future. We're doing more of these, and we need your input so that we can make it most useful. And similarly, I just launched a poll, and I would love to get a sense of if this has deepened your understanding. So please complete this poll in this last minute. And then, like we said, next is data governance. So subscribe to our newsletter to make sure that you get the invite to the data governance topic so that you can learn about privacy and security for the folks you're working with at our next session. And please fill in the poll. I'm seeing 55% have participated in the poll. So let's see some more answers go in there, and then I will share the results. And I just want to start by saying thank you so much for joining us. Thank you for learning with us. Thank you for helping us design these sessions to best serve you by filling in our survey. And thank you for asking good questions and participating in office hours to get them answered that we weren't able to. Have a great rest of your day. I'm ending the poll so we can all see that we had a lot of learnings come out of this poll. So thank you again.